Cool. Thank you. Cool. Thank you. So I'm Qamir Hussain. I work at Webio. I'm the head of AI at Webio. So I have a background in AI, going back over 20 years. I did a PhD in it. Did a little bit of work out in Stanford as well. So that was 99 to 2002. And then I'm back in the area about 10 years, or so, I'd say, since deep learning became a thing. And I've worked on worked with a number of companies, worked on a number of products and whatever. And what I think what everybody's seeing in LLMs and GenAI is just, it's incredible. Like I was talking to a friend of mine I did the PhD with way back when, and like we were working on toy examples like NLP. Like they were really good, but they were toy examples in comparison. Like, so what's going on with LLMs, GenAI is absolutely blowing our minds. So then just as a background to the talk, so yeah, I mean, we're really, I think what's going on here is it's incredibly impressive. And if you're working with AI, I think it's actually very difficult to build good AI systems. It's easy enough to do something small scale. You want a little presentation, and you can edit it if the wording isn't correct or whatever. But then when you move on from there, I think it can be very difficult. So what I'm going to do is just talk a little bit about the inspiration for the talk. A little bit of a background in LLMs and GenAI. A little bit of a talk around some of the tooling around GenAI and LLMs, and what we've done in Webio and what we found to be sort of the way to do it, what worked for us, and hopefully that's things that will help you if you're building AI systems. So a few months ago, I think I was talking to Dave around that time or whatever, I was talking about, so I use Windsurf for my generative code gen stuff. We've loads of options. You've ChatGPT's one, you've Gemini, Lovable. There's all kinds of tools out there. So I started off with CodePilot, GitHub's one, and it was fine. It worked. I used it for a lot of Python stuff, but I didn't really use it for production stuff that much. I used it for a lot of boilerplate stuff. So I hate writing REST endpoints. I just want to go, somebody just give me the damn thing and roll with it, and I can focus on the application. So I used CodePilot for that a lot, for doing things like that, a lot of boilerplate stuff. But I was impressed by it, but I wasn't all that impressed because it didn't do a lot of software engineering stuff. And now, Cursor, Windsurf, all of these tools, they're incredible. They reason so well, they'll generate really good code. They do hallucinate, obviously there's all kinds of issues about it. So again, just the inspiration for the talk then. So I did Windsurf. This was around a side project that I was working on, and I was just vibe coding it. So give it a prompt, didn't really care what the code looked like. I just wanted it to work. And I'd run into a number of issues. One of them was, say something wasn't working, there was a compiler, it'll recognize the compilers and fix it right away. And then it would just say, okay, I have that working now. I'd use it and it's like, it's not working, So it would go into these loops, I found. So I'd eventually be able to prompt it to get it to work. Then it would go into these loops, and that loop mightn't happen for a few days. So I might work on another feature, check it into GitHub, and there's a little bit of back and forth then on that. Then I would find it, I need to add roles, say, in the authentication sort of functionality. I would do some stuff, and it would recreate that code again. And the way it broke, say 3 days ago, it would break again. Then I'd have to say to it, can you have a look at the commits and find when it last worked? Because I forgot the exact time when it last worked, because I wasn't really tracking it. It's AI's job, right? Eventually it would look through the logs, it would find GitHub logs, it would find when it last worked, when I had a message that was something like auth fixed or something like this, and it would figure that out. There's a number of other issues around that. So that really frustrated me, because I felt like, it was still really impressive. It was still writing my code for me. I could be lazy and it would still do the work, but I found it really frustrating. So then what I decided to do was learn how code gen actually works, what's going on under the hood. Of course, I knew a little bit about LLMs, knew something about GenAI and AI and stuff like that. So I had a decent start on it. So, but it still took me a while to figure out how I should best use Windsurf. In my case, I did use Cursor. I switched over to Windsurf at one point. Sort of preferred how Windsurf worked. Didn't really do any major evaluation on it, but I was happy enough with it. And what I found was, one, I should learn Windsurf properly. The other thing was just not vibe code and work the way I used to work, which was to my best ability, think about software engineering as a discipline and all of the stuff that I've learned over 20 odd years or so. Commit regularly, write tests, all that kind of stuff. The other thing that I learned was really to learn about prompt engineering. Now, I've learned a bit over the last few years since prompt engineering has been a thing. I was really cynical about prompt engineering, thinking, yeah, it's just a bag of shite or whatever. Like, is there a real skill, But yeah, it is a real skill. And I had to learn how to prompt Windsurf better, so I would get better results. And it took me a while. It wasn't that simple. So then, just the talk itself, then, what I became really interested in then was, what's the difference between AI engineering and traditional software engineering? And I think the main difference really is that you're going from like a deterministic system to a probabilistic system, or at least one part in the tool chain. If you're using AI somewhere in your product, or if you're using, like I'm doing with Windsurf, is using Windsurf to build something, I need to know how the AI works, that it's not going to give me the same results all the time. It should give me roughly the same results with roughly the same prompt, or how I've set tools up and so on. And then the other part, I think, of AI engineering then is to learn the internals of AI, vector databases, embeddings, agents, and so on. And depending on where you're working, if you're working on product, you may not need to go too deep down, but have an appreciation of what these tools do and how they sort of fit in together. And I'll go through some of these. Okay, so just a few buzzwords. LLMs, large language models. What makes LLMs really powerful is that they have an idea of context. They have an idea of attention, so they can focus on one part or focus on many things. So before LLMs and before deep learning, certainly, and before embeddings were a thing, if you were building, say, language systems, as I did previously, you'd use traditional NLP, NLU, it's natural language understanding, sort of symbolic sort of logic. So you'd say, well, if I see a noun, if a proper sentence is a noun phrase, a verb phrase followed by a noun phrase. Here's a list of nouns. These are swear words. These kind of things. So it was all sort of logic that you'd have to program yourself, and obviously you'd use libraries and stuff for that. So then when deep learning became a thing, and especially embeddings and the transformer models, in which all of the large language models are all transformer models, ChatGPT, Gemini, and all these. They have lots of tooling around it as well for very specific sort of uses. So these are just things that you need to consider. Tokens, that's sort of, it's almost like a word. It's like a number of letters that's used, when you put a prompt in, say, generate, a photograph of a car. The number of letters, letters used is broken up into tokens, and that's how they can cost out how much that particular query might be. You might be sending some data in, like if you're building a RAG application, so where you have thousands of, say, PDFs that you want people to be able to search on and pick out interesting things or whatever. Each one of those rough words or so will be a token, and there's going to be a cost to that. So input tokens sort of relates to cost, I guess. Embeddings will give you context. So just a couple of things with LLMs before we go into GenAI and some sort of applications and use cases of it, I guess. Depending on the application you're working off, and this is what I've found over the last couple of years, is typically you work at maybe one level. You might work at a few levels. Like if you're ChatGPT, you're going to be working at all of these levels. You're going to be doing pre-training, you're doing fine-tuning, alignment, and so on. For us at Webio, we really work at the fine-tuning level. So, excuse me. So what we did was we don't use any of the large language models for anything in production. We can't, because we're a debt collection agency, so we deal with a lot of sensitive information. We're very tightly regulated in terms of where the data stays. So it can only stay in the UK and the EU. So it can't leave those systems at all. So we can't have any kind of data leakage. We have lots of sensitive information, people's names, addresses, all of this kind of stuff. So we have to be very, very careful with that. So what we did was, and this was the architecture that I set up when I started, was we took open source models from Hugging Face, fine-tuned them for what we need. We control everything in the pipeline. So it's a model training, fine-tuning, deployment, the tools around it, and so on. So we work at the fine-tuning level. So depending on what you're doing, I think you'll fit into one of these. If you're big enough, if the space that you're working in is big enough, you might work on a couple of these. So then just a couple of things that I think is very, very difficult in AI and GenAI in particular is context and memory. I think these are the hardest problems. My PhD was kind of in context, but was about context, but that was over 20 years ago, so it was a totally different idea of what context was back then. Now we have embeddings that can give us relationships between words, concepts, and all of that kind of stuff, and that's what gives LLMs so much power to do things like make the car red. You don't have to build the rules for what red is, what a car is. It just knows it because it has some sort of internal representation of cars, colors, vehicles, all of these kind of things. So these, for me, some of the hardest. This and scale are the hardest problems in AI. If context is okay, I think memory is very, very difficult at the moment. So in the case of, say, again, with Windsurf, and there's the back and forth of prompting, reprompting, fixing issues, and so on. It doesn't maintain state. So I use Claude 3.7. I know 4 just came out. So I've been using 3.7 for code gen for the last number of months, and I really like it. I think it's really good, but it doesn't maintain state. It doesn't have a memory between sessions, and this is one of the other frustrations that I'd have. I'd work on something and just close the laptop and go away, and I would open it up, and everything's gone. Now they've iterated on the feature, so you can kind of find those memories a little bit easier. I think they were always there. I just didn't know where to find them. My previous prompts and say the previous outputs that what do they call it? Cascade is their little agent thing. So that's the thing that sits inside of Windsurf itself that has nothing to do with Claude or any of the other models. So that's the thing that can maintain state memory and so on. And it used to really annoy me. I would open up and it's like, okay, where were we? And Windsurf would respond with something like, oh, let me just check, and it would just go through the code again. It would look at commits. It would do all kinds of things, and I was just sitting there going, is this using more tokens now? Will I run out of, whatever I was paying, 20 or 60 quid at the time? Will I run? Because I've had that happen where I've run out of credits, and I had to buy credits, and then felt like I was starting all over again. So there's no state, there's no memory between sessions, so something has to manage that. So the tool that you're using yourself or the tool that you're building will have to have some notion of how to do that and how to do that well. And depending on the model that you're working with in the background, you have different context windows. So you're going to have to build some code in, some sort of logic to manage that. So I think it's really, really difficult. And there's a couple of things, context stuffing and retrieval trade-offs and things like that, that you should be aware of. So just then moving from LLMs to GenAI, broadly speaking there, I think there's two things. One is the reasoning stuff that GenAI does, and it does it really well. And there's a generation, or in our case for this talk, code generation. There are two aspects, and they obviously work together to get some work done. Other things from GenAI, other components, that you can use with GenAI to do all kinds of things, like RAGs, agents, using different tools to do things, multi-step workflow. So multi-step workflow would just be just when you need a little bit of work done for whatever purpose, it does it. It sort of disappears and it comes back in whenever you need it. Agents typically are always live. They're always monitoring things they can change states and so on. RAG, retrieval augmentation, if you're not familiar with it, is a method whereby you can inject an LLM with some information. So you might want to restrict the LLM just to work on, chat logs or something, because you want to, sysadmin they want to know what's going on with how people are using the chat system or whatever. Managing state memory and conversation flow, again, something that you need to be aware of. And again, just to kind of reiterate the point that prompt engineering, again, is a valid discipline, despite what many people would say. So just to sort of repeat a little bit on the coding assistant things. When I was writing these slides, I was thinking about what's the most impressive GenAI application. For me, it's actually what I use day to day is Windsurf or Cursor or any of these sort of tools. Like I think that, despite my sort of frustrations, I think they're incredibly impressive. I've given it my whole code base and said, okay, like the application that I'll be working on the side, I hadn't looked at it, say, in a week. And I couldn't remember what I was last working on, so I just told it, listen, where are we? And I went and looked at logs, looked at other things, and I was able to figure all that out, which I think is really impressive. And so just broadly speaking, there are 3 different types of coding applications. You have Claude code and ChatGPT. I forget is it Chat code or ChatGPT code? Remember they released that? Sorry? Codex, that's it, yeah. Sorry, when I was writing the slide, I couldn't think of it. So there's the CLI, there's Windsurf and Cursor, which is an IDE, and then Lovable and others are web-based. So CLI is probably the most powerful, but it's all terminal-driven, so you have to be comfortable with that, yes. Windsurf is an IDE, so it lives inside a version of VS Code. It's got the prompt on the side, it does all lovely things. And Lovable and other tools like that, they're web-based. So just a quick sort of, from my kind of take on it is, the first generation of code gen applications, syntax completion, quite simple stuff, still useful, but quite simple. And where we are today now, it's not just code gen, it's actually proper software engineering. You can just go in and ask it, look, I'm building this. Can you give me a design pattern that would help this particular scenario? And it'll explain it to you. It'll generate the code. It can write the tests, all of that kind of stuff. You should still validate it, obviously, and look at the code. Don't vibe code. So there's a lot of stuff that it can do. It's incredibly impressive. So then, leaving sort of the code gen applications and things behind it, broadly, there's just some categories that I came up with that I see in every AI application. There's something to do with reliability patterns. You have to do evaluation, you have to do testing. So you might use ChatGPT for something, you might do like a little demo, and then you go into the API and you're building something bigger. So how to communicate with ChatGPT, how to fall back if it fails, can you switch over to Gemini and get the same results, and how would all of that work? Performance and cost is obviously a really important issue. Like for us, both from a performance or cost point of view, neither ChatGPT, Gemini, or Claude are workable solutions, and so the open source open source methods is the way to go. Testing strategies, security, again, just a really, really hot topic at the moment. Again, depending on the application that you're doing. We're kind of lucky in that sense that all of our LLMs and medium-sized models and so on, they all sit on AWS. We have full control over it, so it's not a consumer-facing app, so we don't need to worry about security as much. We do have to worry about hallucinations and stuff like that. So, and I'll talk about that in a little bit. So just before I go into just some examples of AI work that we do at Webio, just how difficult it can be if you're like, say, like Google scale or a really large company. Like there's just so much that can be that you might be working on. Everything from multi-age. If you're designing a really big system, you could have multi-agents. It'll most likely be a hybrid architecture. So you'll have some work done by LLMs and maybe medium-sized models and so on for different types of work. You might have dynamic model selection and routing. So that's where you have some sort of process, some agent that figures out, depending on what's happening, which model to choose and what to do with it. And also, you can go even more advanced and have self-improving, self-healing AI systems. So that's kind of all of sort of the background that I want to talk about when it comes to LLMs, GenAI, and so on. In terms of what we've done at Webby, just to kind of give you an idea of some real-world sort of scenarios. So we started off, when I joined Webby, we started off just with a few small models. I'm going to say small, they're tiny. They're very fast, they're very easy to fine-tune. So at the start, there was lots of fine-tuning. We got it to a point where it did the work that we need. So we did a lot of classification work at the start. So that's figuring out intents and entities from conversations that were going on, all under the hood. And then we'd flag them, send them to the dashboard so our customers would know what's happening and they could automate some sort of process out of it. So just as an example, it could be something like somebody might send a message in to say, sorry, I lost my job. I can't make any payments for the next few months until I get work again. That might be the message they send in, as one of our customers might say, look, you owe us £100 or whatever it is, and this might be the response that they get. And we can flag that as being vulnerable, in which case it goes to a particular queue where a human agent can give them a call or drop them a message and say, sorry that you're going through a hard time, should we talk again in a few months, or maybe if you can drop us a message when the situation improves or whatever. Again, one of the principles that we have is empathetic AI. We're concerned about how the end user, the end customer is doing, and to make the system work for them. We have different size models. So we have tiny models, we have small models, and we have medium and large language models. And I think that the right decision that we made early on was to be very specialized. One, the niche that we're in, so it's just credit and collections conversations. We don't care about recipes, we don't care about pizzas, how to make the world's best pizzas or any of that. So if there's irrelevant messages or conversations that happen, they just get put into a bucket of out of context or wherever. Don't waste any time on anything that's related to people going through a hard time, or somebody just wants to make a payment or whatever. We can automate that and save time for our customers and make everyone in the loop sort of happier, I guess. So we specialize uses. So the industry that we're in is very specialized, but also the models themselves. We have about 5 or 6 different models that do different things. So smaller models obviously are great at classification. They're very cheap to run. They're very cheap to train, which is a big deal for us. We have a couple of large language models, and we use them for things like summarization of conversations. So we started off, we used ChatGPT. We just gave it some like demo conversations, and it did summarize the conversations, but they weren't great, and we're doing this at scale. So we have millions of messages and conversations every month. We use ChatGPT just to kind of get a sense of how good, the state of the art is. And we went to Hugging Face then again, and we evaluated a whole bunch of LLMs that are very good at text summarization. And what we found was at the start, it's fine for, say, conversations that are about, say, 10 messages long. It was able to pick out the pertinent details. It'd be something, a summary might go along the lines of, this person, Jane, she lost her job 2 months ago, but she can make a payment next month. Something like this. It might be, we have 3 bullet points, is typically the thing that we look for. So anything that was like 10 messages, so was fine. Between 10 and I'd say 10 and 20, it was okay, but it would hallucinate a little bit. Beyond 20, it was just, it was terrible. So then we picked the model that did the best job at the short and medium-sized conversations. Then we fine-tuned it, and we fine-tune it continuously as we evaluate how well real-world conversations are being summarized. And to support that, so that's kind of one of the typical use cases that we have for LLMs and GenAI. so we built tools around that to constantly evaluate how well it's performing. So, we can only look at, I don't know, 10, 20 conversations a day if you want to evaluate how well it's summarized it. But we have millions of conversations, so we want it at a larger scale. So we had to, for the LLM work, for the summarization work alone, we had to put in a vector DB to do the evaluation. So the vector DB would store the summarizations, and it would score it basically and how well it's summarized, and then we'd have some manual checks as well in there. So just then, for the rest of the stuff in Webio, I guess the pipeline as well we created stuff. Now it's quite simple. It's we didn't need to kind of take some open source tool and work with that. We just built our own pipelines in terms of deployment, in terms of evaluation. We have a few tools to manage the testing of different models, to manage our models, to manage the training. So we built all of that ourselves. It meant it took us a bit longer to kind of get things up and running, but once we had that, it just meant it's very fluid, like it's very, very automated at this point. We have some RAG as well for some knowledge base stuff. Again, we looked at a few YouTube videos on RAG, a couple of techniques and so on, and then we just kind of built a custom version of that for our own needs. So just to sort of wrap up then, have a look at what's going on. Have a look at what LLMs do, how they work, how GenAI works, some of the tooling around it, and then just remember that there are a few areas that I think are incredibly difficult to deal with. One is scaling. So you could take an open source model like we did, and let's just say you want to build an email spam classifier because you don't like Gmails when you want to build something a little bit better. So you might find a model that's really good at detecting spam emails. And then you might also want to summarize emails, as we do with conversations. And you might find the model that does the classification is terrible at summarizing, so you might have to find another model. So just bear that in mind. Don't just think of that one model or even a number of models can do everything. You might need to just add some code to bridge some functionality. So scaling AI systems is I think very, very difficult. Context and memory, as I mentioned before, is very difficult as well. If you need to add a vector database for whatever purpose, you'll have to learn how vectors work, how vector databases work, and so on, and how they work in your application. Memory, again, if you're working with different models, you're going to be working with different token windows and so on. So again, you'll have to understand that. And it's the case with both closed source, so with ChatGPT and Gemini and those, as well as open source. You're going to face the same issues as you try to scale up on how best to do it. So just to sort of, I guess, to wrap up then, finally, at Webio, the two things that I wanted, because I'd worked in the area before, was that I wanted the work that we did to be really high quality. I didn't want customers to see something and something that's vulnerable is actually somebody trying to make a payment, things like that. I didn't want to have to deal with those issues from a support point of view. So understand the fundamentals of the AI components, as I mentioned, and think about architecture. Think about how different components will work together and how to, and think of it as a sort of an ecosystem, not just as here's ChatGPT, we have an API, just figure out how to prompt and it'll take care of everything. It'll get you a good bit of the way, but to get it to a level that, say, we wanted at Webio, at a very high quality, and easy to manage as well. These are the other things, and that's why we built our own tools so that we can manage our data and models, as robustly as possible. And finally, design for uncertainty, embrace sort of probabilistic thinking that depending on what you're trying to get the LLM or GenAI to do, you may not get the same results next time. If ChatGPT, and this has happened a number of times, they improve everything, all of their benchmarks improve, but the one thing that you're using it for, it actually got worse, and now you're stuck. So that's it. Thank you. we go for the tiniest one and we go up rather than going big one, go down. Because we try to, where we can, try to build it on our local machines first before deploying onto AWS. If we can't do it right away on our local machines, we all have beefy enough sort of machines, but not in the same scale as, say, AWS with whatever number of GPUs or whatever. So we'll try to get it running on our local machine just to do the evaluation.
Yeah. So you try to create
we work up.
AWS knowledge and then
Yeah.
that's the work you get more.
Yeah, so the way we would work is we would just look at something that, in quotes, does the work, download it. We've loads of data, which we're really lucky to have, real world data that we can just fire at it for whatever we want to do. One of the things to say, OCR is one of the things that we also do. So downloaded a model or two, took some sample sort of driver's license. This is just one of the things that we provide, which is identification and verification, where somebody can say, take a photograph of the driver's license and just put it in. Oh yeah, I'm talking to David Curran. Okay, I can talk about your account now. So we just took the smallest model. There's a little bit of code around it that we need to write to make it happen. And it worked reasonably well. Then we fine-tuned it, and then to kind of get it to work properly, as we added more stuff to it, we couldn't run it on our local machine, so we had to then put it on.
You get it running pretty well locally. You think it needs to be better, bigger, then go bigger.
Yeah, I mean, there has been times when we've just said, okay, this needs an AWS thing with, I don't know, whatever, 8 GPUs or something. So we'll just do it on that and then do all of the evaluation. But we tried as much as we can do the initial work on our machines.
Cool. Sorry,
Any other questions?
Yeah, I'm just curious about windsurf because I haven't heard it before. So, is there something you can tell us about that? Like, what would be the best use case?
So have you used Cursor?
No.
Okay. What I'd recommend you do is try both of them, and try it on something that you code up anyway. Say something that you've done before, because that'll give you a sense of how good it is. So in my case, when I first started off in the code gen journey, I was using Copilot, so I said, I'll buy a license for it. Like it's 100 quid. I was like, I'll buy a license for it. And I was just getting to do all the stuff I really hate, which is writing API endpoints, because I have to sit there and go, okay, I need something to get me a list of all of the things, one of the things, and then wrap it around like a get, post. It's like, it's an absolute pain.
So it generates the code for you.
Yeah, so it's actually it's an ID.
Okay.
So it's VS Code, and it'll connect. It'll have a list of models. So if you have a model that you prefer, starting off, I would say just pick Claude. I think it's the one that I use, and you can play around with. You can switch it over to Gemini or whatever, and they have a few pricing plans. So $20 a month and then $60 a month. You just get more interactions with it, basically. So what I'd say is just try both of them. I know you'd be comfortable with IDEs and stuff.
Okay, so sorry, you're using VS Code to create an AI agent, and you're using Windsurf to assist you in writing.
Yeah. So
Okay.
yeah. So basically, Windsurf, like you just put the prompt in. Give me some endpoints. The nice thing actually, if you're using Claude as the model in Windsurf, you can give it screenshots. So it's done a HTML page, but you don't like the look of it. You can just take a screenshot and just say, listen, the colors are all wrong. Put it in, and it'll fix it for you. Sometimes it won't, whatever. But does that answer your question, sorry?
Yeah, that's more clear. Thanks.
Cool. Yourself? Oh, so good.
Okay, so I just wanted to ask, what was the flow to optimize your summarizing model? So you picked a model from Hugging Face, and you from what you explained,
Yeah.
you ran it on the machine. So how did you test? It is good at summarization.
It's a good question. It was actually a lot harder than, we didn't think it was going to be of course, engineers, we're very optimistic. We're like, okay, there's one example, we gave it 10 messages. Oh, this is really cool. It'll solve all of our problems. Then the hard work starts. What was happening was it would fall over all the time. Even on AWS, we would pick the smallest server we could get away with. Because I know how server costs can just run amok And we don't have massive budgets, like we don't have ChatGPT budgets, you know. I wish we did. So we would have it run, say, I'm just going to say it was 4 GPUs as basing in, like, I don't know, 6 gigs of RAM. And it would be fine, and you would send it 3 conversations and it would fall over. It was fine at 2, 3 would fall over. So then we'd have to bump it up a little bit more. Where the interesting work came in, and I think this is what you're alluding to, is how do we test? Well, how do we test the summaries? So from product, they wanted like a 3-line summary, so 3 bullet points to say, you know, customer lost a job, but they can pay, you know, £50 in 2 months' time, and here's their new number. Let's just say that's the full summary of the conversation. So we would get the summary back, and we would do. Now I didn't do the work in this, but we'd have, I think it was cosine similarity, and there's a couple of little tests like that you can do. So we would store all the summaries in a vector database, and then we would have, like what we do with the classifications, like where somebody's like a message is flagged as with a particular intent, like I can pay tomorrow, that's a payment. So it's a very simple thing. Is this message a real payment or not? For the summaries, we have huge amounts of data, right? So we have lots of labeled summarizations. So we'd go through the summaries and just say, yeah, these are all correct. These are all good summaries. And then, so that's in the vector database, so that it can automatically do a comparison to see how close it is. And then we still have a human evaluation.
Someone wrote those summaries manually and then you used it for evaluation?
No, we got it to do the summaries, and then somebody just checked to see, was that summary an accurate reflection on the main conversation. It was really tricky. It was an absolute pain, I have to say. Like it took us just lots and lots of iterations, because we had to learn and I don't remember the model. I think it's a BART-based model, but don't quote me on it. The model that we ended up just going with for the summaries itself, like we had to learn how to fine-tune it. So this whole tutorial, and you go through it, and of course some of the steps are fine, other steps just don't make any sense, and so there was quite a lot of work in getting that kind of the process stable. Yeah, I hate text summarization, by the way, just say that. So good.
Copilot has an agent mode as well. So did you try that?
I haven't, because I think
it does the same thing. It is much more better than just ask, and you can even do with models.
Yeah, I think that came out like a little while ago. Now I use.
It only came out, I think, just a month ago.
Okay.
I started with last month. I just started testing it.
Okay, because I use. I think I'm trying to think off the top of my head. I think it was like 2 years ago. I started with Copilot, and it was okay. Like I said, it was okay, but I just found there was lots of back and forth, and I didn't stay with it. How have you found it? Have you done much work with it?
Yeah, the agent mode, it's far more better,
Mm-hmm.
because I tried with both ask and agent mode.
Okay.
In agent mode, however, you only get 300 requests if you have Pro.
Okay.
Version. So after that, you have to pay more.
A lot more.
It does give you all the things and new models, and it does give you everything that it takes the whole context of your code.
Okay.
It does the same thing that you were telling me.
Yeah. And have you used Cursor or Windsurf or any of the other tools?
I haven't used Cursor, but I have heard about it.
Okay.
But I went the Cursor can also do MCP, and Copilot can also do.
Yeah, because I'm curious, because I haven't really done like a proper evaluation comparing things. It's just, I think it's a huge amount of
I
time.
think they probably did it recently.
Okay.
Maybe watching Cursor or something.
And what model did you use, if you don't mind me asking?
Clock 3.7.
So it's saying.
It was the best one. It had everything from 4.1 to everything, but I think Clock 3.7 performed the best.
Yeah, that's what I'm sort of comfortable, I guess, with that. I switched over to Gemini. Do you remember, I think, was it like a month ago that Gemini was rated as the best coding engine? And in Windsurf, I just decided to select it. And one of those issues that really frustrated me, I said, look, this is what's happening. Can you just have a look and fix it? And I was just waiting, and it did nothing. It actually did nothing. It's like, fuck this. I'll just, go back to 3.7. Now I'm sure there was just, I don't know, there was like a little bug or something. Like I have used Gemini outside of it, and the one-shot prompting to build something. It is really, really impressive. And I think it just goes to show that depending on what tool you're using, you could use the world's best model and get worse results than the one that's second best or whatever.
I think like it's my personal experience. Like you have to change the prompting the way when you change the model dimensions. Like if you change using OpenAI and
Yeah.
then you use the same prompt on Cloud or Gemini, you will not get the same results.
Yeah. So
You
like,
change the prompting the way the technical prompting itself.
yeah, I'm wondering if that's the way they're trying to make the product sticky. So once you get used to, like, it's funny because just as you say that, I'm thinking I can't imagine myself using something other than Windsurf because I'm just so used to it now. Even though, let's just say, Cursor is much better. You know, I'd have to come up with a project that I can use on and make that evaluation. Whereas I know, with all the frustrations, like I said, with all the frustrations with Windsurf, I feel like I can make it work for what I need it to do. So yeah, no, good point.
So, what did you do to make Windsurf or Cursor to remember what it has done before?
So they've sort of improved all of those features because obviously it's something that everyone's going to come across. So it does a better job of remembering the last few steps. I think they now have a tab, if I remember correctly. It might have been there, I just didn't see it. I think the UX needs a lot of improvement, by the way. A lot of improvement. So there was like a little drop down somewhere where I could just click on it and it would just show, say, the last 5, and I could scroll back to see all of the last prompts and its responses. Because sometimes all I needed to do was see what I was working on yesterday, which I just forgot, or 2 days ago, or whatever it happens to be. So they've improved all of those features just from a UX point of view. I suspect it was kind of always there, but I didn't know how to activate it. So what I would do is just say, where were we? Or I think we were working on auth and there was an issue with this. And then it would say, okay, let me check. And it would go and look at the source auth folder and just see what the last updates were. Because with its reasoning, it's able to figure out files that were last changed or last committed, all of that kind of things. So it would to try and remember. It felt like I would give it a prompt and it would just go through files and commits to figure out what it was last working on. And on that, it actually did a really good job.
Yeah, I think it might be a good idea when you start a new section, then you just let Cursor to scan the project and to remember the decision you have made.
Yeah, like
which database and so on.
Yeah, like actually tell it or ask it what it was last working on. Yeah. Cool. Did somebody else have a question? Yourself?
I was just going to comment on when you're comparing like a larger model or the second best model could be better.
Mm-hmm.
I had a case where I trained a GAN model from scratch was much better than fine-tuning a foundational model.
Okay.
So, but this was a segmentation case and I was using SAM. So
Okay.
I just found like foundational models might be good, but just training a model from scratch is much better.
Yeah. I mean, I found that like soon after a year after I joined Webio, seeing all of this stuff, LLMs, this, and it'll do everything for you. And I was just thinking, well, we could get it just to do all of the work that I've been doing up to that point, say a year or so of, fine-tuning open source model. We didn't build anything from scratch. We just took customer service models that we could use in a commercial sense, and then fine-tuned it. And I remember just kind of getting worried that like we can just give it to like ChatGPT, and I don't need to be here, But it wasn't the case, One, it was really expensive. 2, it was really flaky. Obviously, it's gotten a lot better now. There's loads of issues, and like I found, like for classification, old NLP stuff was perfect, and it's tiny, it's really cheap, very performant.
Yeah.
Like if that was an LLM doing exactly the same work, the cost of computation, I don't know, like 1,000-fold or something.
Yeah, we had the same problem. Like the cost for fine-tuning the foundation model was much more. It was more time-consuming as well compared to actually the conditional GAN that we just created was much faster.
Do you mind me asking, how long did it take you to get the work that you were doing to a level that you were happy with?
With the GAN model?
Yeah.
So if I kind of trained the foundation model, it took me a week. If I trained the GAN model, it took me 2 days.
Okay.
So
very good.
Yeah.
Cool. Do you want to wrap up or?
It seems to be a good point to wrap up because you're actually talking, so as soon as you stand up, the conversation keeps going.
Happy days. Cool.
We're just going straight across the river if people want to join us. Most of these have been there before, so that's kind of where a lot of the fun is. So thank you very much.
Cool.
It was really fascinating. And thank you to Carmen for
Cool.